how variables are related in scatter plots. All right, so the first blank is scatter plots. So fill that in. One, let's make sure we're eyes open. What are you doing? Go over there. There's one on the wall. All right, a scatter plot is a graph in which the values of two variables are plotted along two axes. All right, that's what a scatter plot is. The points do not connect. That's why they're called scatter plots, because they're scattered. The pattern of the resulting points reveals any correlation present. So that's what helps us determine other conclusions. All right, two variables show a pattern. They're probably connected in some way. So this blank is a correlation. It is a measure of the linear relationship between two quantitative variables. There is positive correlation, negative correlation, and no correlation. All right, so what do you think a positive correlation would look like? Going up from left to right, so that's also hand movements, good. So positive correlation will look something like this, where the data is trending upwards. So as X increases, so does Y. All right, what do you think negative correlation looks like? Good. So something like this would be an example of a negative correlation. What would no correlation look like? Straight line like this is one example. How else can it look if there's no correlation? Is this the only way it looks if there's no correlation? What about this? Where it's all over the place. All right, that's also no correlation. All right, so there's two examples there for no correlation. That's data that seems to have no visible relationship between them. All right, so think about like in real life when you might see positive correlations, negative correlations, and no correlations. So like positive correlation can be like X could be the number of sales and Y could be the amount of money you make, right? As one increases, so does the other. Negative correlation is where one increases and the other one decreases. So what do you think about that one? What is an example of negative correlation? What's an example of it? Like a real world example. Spending money. Good. So the more money you spend, the less you have in your account, right? What would be an example of no correlation?
Stock market.
Like it's random, there's no clear trend. There could be positive and negative trends though, and no correlation. So here's an example of no correlation. Like the amount of ice cream you eat and the number of sunburns you have. Is there a relationship between those two? No. No, so that'll probably look like this graph. Over here, the straight line, here's an example of that, which is a little bit weird, but it's the only one I can think of right now. The age that you are versus the amount of shoes you wear at one time. 2, because it's like constantly 2, right? No matter what age you are. So that's why it would be a straight line, because there's no real relationship or trend between them. That makes sense? Any questions? All right, so then one way to quantify the correlation of a data set is with something called the correlation coefficient. You're gonna have to squeeze that in there. But the correlation coefficient is denoted by R, so it's also called your R value. So make that note there. All right, I know your test calls it an R value. I know your exit ticket calls it a correlation coefficient, so just be comfortable with both. And that's a value that varies from -1 to 1, so that's what goes here. -1 to 1, with the sign of R corresponding to the type of correlation, positive or negative. All right, strongly correlated data points look more like points that are on a straight line. And those R values would be closer to 1. And then it's positive or negative depending on the type of correlation. Weakly correlated data will have values closer to 0. So I kind of mentioned it before in the success criteria, but that R value is what we had to use a lot in college to determine if our data was good and if we could use it. And it had to be a really strong positive R value. So the closer it was to 1, the better. So anything from like 0.95 to 1, we were allowed to use that data. Anything below that, like 0.944, could not use it. Right? It wasn't strong enough. Yes. All right, but any questions so far? All right, so then down here, we're going to describe the correlation and estimate the R value. So how would you describe the first one? Is it positive, negative? Negative. Good. So it goes along with your slopes. I have a negative slope, then I have a negative correlation between the variables. Would you say that this is a strong negative correlation or a weak negative correlation?
Strong.
And why do you say that? It is strong, but I haven't heard the correct reason why. The correct reason why is because it's really close to being in a straight line, right? I mean, it's not exactly, but it's close. So these lines that are drawn through the data are called lines of fit. All right, we'll talk about those more on the back side, but the closer it is to that line, the stronger it is, and the closer to 1 it probably is. Now we have to estimate the R value. I know on your test, it'll give you like 4 options, pick the best one. For this one, it gives us 5 options. So -1, -0.5, 0.5, or 1. Which one do you think it'll be closest to? What do you think? Not 0.5. Not 0, because that would be no correlation. Not 1, because that's for positive correlation. So -1. R is closer to -1 for this first one. Because it's a strong negative correlation. The stronger it is, the closer it is to 1, whether it's positive or negative, depends on your slope. Does that make sense? All right, let's try this one. Positive or negative?
Strong.
Good. And yes, I would agree that it's a strong positive correlation. And what would you estimate that this R value is closest to?
One.
Good. All right, try the 2 on the bottom. So practice classifying it and estimating the R value out of those 5 options. So bottom left, how did you classify it? Negative, anything else? Good. It's definitely a weak negative correlation. Because do any of the points touch the line of fit? No. So definitely weak. What did you estimate the R value as? Good. If you thought 0, 0 is for no correlation. So there's still a correlation going on because you can see that it's negative. So it's more just a weak negative. Does that make sense? Okay, keep side conversations to a minimum. On the right side, what did you classify that one as? Weak, positive. Good. Weak, positive. What R value best matches this one out of the 5? Good. Questions? All right, anyone understand or not understand the positive and negative part of it? All right, so on a test, you should be able to weed out the bad options. All right, so now on the back side. Yes, the lady there. So then on the back side, we have what's called a line of best fit. So sorry, you'll have to squeeze that in there or write it in the margins. But it's also called a trend line. So we have a line of best fit, also known as a trend line. Those mean the same thing. I use them interchangeably, so get comfortable with both. But like I mentioned before, it's a line that goes through a set of data to illustrate the correlation. So when there's a strong correlation between the 2 variables, you can use that line of fit to construct a linear model for the data. So in more like student-friendly terms, I can use the line, the y equals mx plus b line, to estimate for any input or output that we didn't necessarily collect in our experiment or in our data set. So like you see all these dots down here. All right. So that shows that we measured for like almost 15, almost 30, things like that. Well, now I can measure for when I had 10 or 70, things that we didn't necessarily collect using our y equals mx plus b. So when estimating the line of fit, draw the line that the data points appear to be clustered around. So fill that in here. You're going to draw a line that the data points appear to be clustered around. We'll add this to the line. So I shot you to go now. It is not important that any of the data points actually touch the line. Instead, the line should be drawn as straight as possible and go through the middle of the data. So we're not playing connect the dots. All right, we're not necessarily drawing a line where most of the points can touch that line. We're drawing it where the data is clustered around it and the line goes through the middle of the data. So like pretend that this blue line wasn't here. What I usually tell my students is like take another piece of paper and measure it up so that it's going through the middle of the data. And then draw your line. So it's important that it's as straight as possible. Questions there? All right, again, we don't care that any of the points actually touch the line. It just needs to go through the center of the data. So first example, we need to write the equation of the line of fit. So first, and the steps are written out for you, so make sure you memorize these steps. We need to identify 2 points that appear to be on the line. Do those 2 points need to be the data points? So the black dots? No, they do not need to be the black dots. They can only be the black dots if it's on the line of fit. Are any of them on the line of fit? No. Maybe this one is close, it touches it, but it's not centered, so no. So tell me a dot, not a dot, but tell me a point that is actually on that blue line. Just throwing out there.
40, 60.
40, 60. Sorry, it's hard to see. 40, 60 is here. It's not exactly on the line.
Other way around.
60, 40?
Yeah.
Okay, good. I would pick that one too. Let's see. 10. 100 would be up here. Do you mean 1095? Okay. What was the other one you said? 55, 45 works. Good. What's another one we could use? 1590 would also work. All right, as long as it's on the blue line, it would work. All right, and try to pick ones where you're doing less estimating. So like the ones you guys said work really well because you're not like guessing where the line goes through. So good. We'll pick the first 2 that you guys pointed out. So we'll pick 1095 and 6040. Questions there? All right, so notice it's not any of the black dots, it's dots that are on that blue line. Now, you guys should know how to calculate slope between 2 points. At least you should, because it was tested on our last test. So what's the formula for calculating slope between 2 points? Good. Now, you can probably argue with me if you want, but I don't make you guys remember a whole ton of formulas. But this one is one you need to remember. Use it all year. So memorize that one. So that's how you calculate the slope between 2 points. If you don't remember how to use it, here's how. Label one of your points as x1, y1. The other is x2, y2. And plug them into the formula. So if I label it like this, my y2 is 40 minus y1, which is 95, good, over x2, which is good, minus x1, which is 10. And I color coded it so that you can see it. But notice like the numbers that came from the same point should be on top of each other. Always be the y over the x, not the x over the y. Some of you guys made that mistake on your last test. Question so far? Now let's simplify it. What's 40 minus 95? Negative 55. And then 60 minus 10. And I'm gonna put that in my calculator because I want to see what like the actual m value is. It's okay if it's a decimal for these purposes. And I get m is equal to negative 1.1. Questions there? Any questions? All right, now from here, you guys should know how to solve for the y-intercept, but still I have kids asking questions every day. So here it is again, like the third or fourth time now it's shown up in the lesson. But what you have to do is plug in the y, m, and x into y equals mx plus b. And I'll do that over here so that I have enough room. All right, what did we say that the m is? Your slope, and we calculated it to be negative 1.1, so we're plugging that in. Where can I get an x and a y from? You could get it from the graph, or you can also get it from the one of the 2 points that we used. So I'll use this one. For this one, which one's my y? Good, so plug that in. My x is, and then plus b. And solve for b. Questions? All right, so again, we get the x and y from one of the points we use. Now, what is negative 1.1 times 10? Negative 1.1 times 10. Negative 11, right? So I have negative 11 plus b equal to 95. How do you get the b by itself? Add 11. So think about what you need to do to make it 0. If I divide it, it'd become 1. Right? And we don't want 1 plus b, we want 0 plus b. So cancel it out. What's 95 plus 11? 106 equal to b. Questions there? So we solved for the y-intercept. Now, last step is to just put it all together. Write the equation in slope-intercept form. So y equals, what did we say the slope was? Negative 1.1x plus our y-intercept, which we said is good. Questions? All right, that's how we estimate the line of fit. Scientists will normally use a computer. They don't necessarily pick 2 points off the graph, but that's what you guys know how to do. So that's why we're estimating it in here. Now your answer options on a test might not be exactly this because this is an estimation, but it should be really close to this. So like look at our answer, should be on your paper. And now I'm going to show you what it was last year when I taught it and when we used different points. All right, so here's what we did last year. Oh, did we use the same points? Well, that's no fun. Okay, let me pull up on the day's notes because I did already post them. We used a different set of points earlier today. All right, so we use 1095 and 1510. Same process. Isn't our answer really close to this? Negative 1x plus 105, isn't our answer really close? So that's why it should still be really close to one of the answer options. It just might not be exactly the same answer. Questions there? All right, so try the one underneath it, the your turn. Don't pack up until 10:54, okay? Just do as much as you can on the your turn.